Hey there, Mustangs. Welcome back to another edition of No Hair, No Problem. Before I get going here, I got a little story to share with you. Yesterday, I was actually on the way home, driving home, and while I was driving, I got pulled over by a police officer. And police officer comes up, knocks on the window, and he says, "Hey, do you know why I pulled you over?" And I tell him, "Hang on a second, I'm on the phone." Anyways, all right, so let's get started here on today's lesson. Today, what we're working on is rational exponents, also known as fractional exponents. Okay, you definitely want to use a calculator for this. It's going to help make things go a lot quicker, and it's going to help us with checking over our work. I'm going to try to do things by hand, but feel free to use a calculator as much as possible. So let's get started. With the first problem here, it's just a simple algebra review. When we're doing x is equal to -6, we're taking that and we're plugging it in for each one of the x's that are in this problem here. So what does that look like when we make that substitution? Remember to use parentheses whenever we do the substitution. That's why we keep practicing this. So that -6 is going to go in for each one of those x's in the problem. Everything else is still going to stay where it is. So we're going to have that squared, -5, and -4. Okay, so then we're going to throw this into the calculator or just follow orders of operation. That we're going to do exponents first, which will give us 36 right here, because -6 times -6. And then -5 times -6 is +30, and then -4. So we have 66 minus 4 as we go from left to right, which is 62. Okay. So now let's talk about the actual fractional exponents. This is, again, you notice the word here, calculator. It's really helpful to use this. You don't have to, but I'm going to encourage you because it's going to help save some time. So let's review some of the rules here first. When we're looking at multiplying of exponents, like we do see here, when we have x to the 10th power, that x to the 10th is the same thing as saying x 10 separate times. Okay? That x to the 3rd power, that's x to the 10th there, that x to the 3rd power is like saying we have an x 3 separate times. When we look at the combined total of these, you can see that there are 10 x's in this first spot, and there's 3 right here. Putting those together, there are a total of 13. Well, how do we get that? You simply take the 10 and you add 3 to it to give you that 13. So when we take a look at problems with fractions, don't be fazed by the fractions. The process is still exactly the same. This is like if I had a 5 right here and a 2 right here, you would take those and say 5 plus 2. And since we have fractions here, you're still going to do the same thing. You're going to say 1/5 plus 2/3. So again, this is where you might want to use a calculator. But if we did this, it would be 3 plus 10, so it's going to be 13 over 15 when we add these together. Okay? If we take a look at number 3, and what I would suggest is at this point is pause the video, try to do number 3 and 4 on your own, and then come back and actually check your answer. Okay? But if we were to continue on with this, we're going to take and do x to the 1/4 plus 4/9. That means we're going to have x to the, what is that, 9 plus 16, so 25 over 36. Okay. For the next one, we're going to do the same thing. We have x raised to the -2/3 plus 1/4. Okay. That is going to give us a -8 plus 3, so a -5 over 12. So this will be an x to the -5 over 12. I'm going to check that just to be safe. See, even I use a calculator, but I just want to be safe. I'd rather be safe than sorry, right? But we are going to go ahead and put this in, and we get -5 over 12. So you'll notice in this example, we end up with a situation where we have a negative exponent. And we just finished the unit on this where we said anytime there's a negative exponent, those are not wanting to stay negative, that we want to switch those to a positive. So what that means is we need to take this and rewrite it so it's in the form where that negative exponent gets shifted. Well, if we were to take this and write it, hang on. If we took this and wrote it out, it would be right here as a negative on top of my fraction. But because it's a negative, it's going to move down to the bottom, and when it moves, it turns into a positive. The problem is that when I look at this, there's nothing that's holding that numerator, the top part, so we throw a 1 in there just to hold that position. And this is our final answer. Okay? If we take a look at divisional rules, same rules as what we had previously. that if we think about the war, it's the North versus the South, okay? We have, remember there's 12 A's here. So there's 5, 6, 7, 8, 9, 10, 11, 12. And in the denominator, there are a total of 4 A's. And so remember we said the North decides to, say, all right, let's go get the 4. Let's attack them. And they go and they attack each other. And there's a little fight that happens. One of these A's will take out one of them. One of them takes out the other. One takes out the other. One takes out the other. And so you look at what we're left with. We're left with 8. Well, how can we have gotten that faster? If you remember, we take these two numbers and we say it's a to the 12 minus 4 is going to equal 8. Okay? And so when you're doing fractions with division, it's the same exact thing. Okay? Not everybody's really good enough with fractions to recognize which is the bigger number, which is the smallest number. So we just do subtraction just to keep our lives easy. So when we look at this, it's going to be x to the 4/5 minus 1/2, just the top minus the bottom. Simplify this, we're going to have 8 minus 5, which is x to the 3 over 10. And if we look at that, it's a positive, meaning we're done. We don't have to simplify any further. Okay? All right, the next one, again, I would pause this, try it on your own. Okay, see if you can get your answer. But it's the same process, x to the 4/3 minus 1/7. So that means we're going to have 28 minus 3, which is 25. Oops, we got to put the x first. Doi. All right, and we're going to have x to the 28 minus 3, which is 25 divided by 21. Okay, throw those in the calculator, try to get them. All right. Next one, and these are the last problems, is using the power rule. And if you remember for the power rule, we take that power, whatever that power is, and we're going to distribute it to the inside. So this 1/2 that's right here is going to be distributed to every single thing that we see inside of this problem. So what does this look like? Start by first writing each part that we see inside the fraction, inside the problem, as separate portions that are raised, that are in parentheses, c to the 4th. And what we're going to do is we're going to raise everything to that power. So we're going to have the 1/2 on each one of these. Okay. And if you recall, the rule for when we have a power raised to another power is you multiply the powers together. So this first part, when we look at it, this portion right here, I can't simplify that at all in terms of like any power things, but I could put this into the calculator. And 16 to the 1/2 power is going to give us a 4. Okay. The exponent on the next part here, when we look at it, is, let's see, we got half there. These two, when we have a power raised to a power, you multiply them together. So 12 times 1/2. That means that we're going to end up with half of 12, which is 6. Continuing on to the next one, we're going to go ahead and do the same thing. We're going to take our powers that we see here, the 1/2 and the 8, and we're going to say 8 times 1/2, and that means we end up with half of 8, which is just 4. And then for our last part, we have the C's, okay? And again, same exact process. We have a power raised to another power. That means we're going to go 4 times 1/2, which means we have c to the 1/2 of 4, which is 2. So this is our final answer here. There's no negative exponents, so we don't have to worry about moving anything. This would be the final answer at the end of it. Okay? All right, so pause it. Try to do the next two problems. Okay? I'll go through and start working those now. Same exact thing as what we just did. This 20 is going to be distributed to everything that we see in the problem here. So let's write each one of these out. We have a to the 1/5. Okay, we have b to the negative 1/2. And we have c to the 3/4. And all of this is going to be raised to the 20th power. Okay, so let's go part by part here. We have this first part here, which we're going to take the exponent since it's a power raised to a power, and we're going to multiply it. So 20 times 1/5. And that's just taking 20, dividing it by 5. We end up with a to the 4th. Let's go on to the next one. We're going to go ahead and do the same thing. We're going to have 20 times negative 1/2, which means we end up with b to the negative 10, because half of 20 is 10, and it's a negative. And then for the last part here, we're going to have c. And if we go ahead and throw this in, we're going to have 20 times 3 over 4, which is going to be c to the 15th. Now, when you look at this answer at the moment, because we still have a negative exponent, we have to go ahead and still make some movements in this problem. So that b to the negative 10, it has to move. We don't want to leave it as a negative. But the other ones, which are positive, that that a to the 4th and the c to the 15th, because those are positive, those will stay. So when we do the keep and move, let's see what happens here. We're going to keep a to the 4th where it is. We're going to take this b to the negative 10, and it's going to move down and become a positive. And then the c to the 15th, we're going to keep, and it's going to stay where it is as c to the 15th. Okay, so this is our answer. All right, and then we have one more question. Again, pause it, go back and try to watch it, but let's go ahead and work through this. So we now have 1/4 is on the outside. That's going to be distributed to everything inside our problem. You can see there's 4 distributions here. The first one for this is that 625. The next one is that a to the negative 20. Then we have b to the 80 and c to the 4. So I'm just taking each part that's inside of our fraction, or inside of our problem, and just breaking them up. And now let's take that 1/4 and put it on each item here. Okay, it's distributed now to everything. And we'll go through and do the same process. First thing first, 625 to the 1/4 power. That is going to equal 625 raised to the 1/4. Yeah, it is. It's 5. Had a brain fart there. All right, so this is going to equal 5. Okay, that's just a coefficient, so there's no variable to actually deal with there. You just calculator. All right, the next one that we have here is we're going to take a to the negative 20th to the 1/4, and we will have negative 20 times 1/4, which means that we're going to have a to the, it's just times, sorry, it looks like a negative there. That's going to equal a negative 5. We're going to go ahead and do b to the 80 times 1/4. So that means we're going to have b to the 20th. And then last one, we have a c to the 4th raised to the 1/4. And that means that we're going to have 4 times 1/4, which is just a 1. So we have c to the 1st. And then whenever we look at this and we have negative exponents, remember those move. Everything else is going to stay exactly as it is. So if we move the items that have to be moved, let's go one thing at a time here. That 5 that we see right here is going to stay where it is because it doesn't have a negative exponent. The a right here is going to move because it's got a negative, and it's going to be turned into a positive. The b to the 20th will stay where it is, and then the c to the 1st will stay where it is because it's a positive exponent. And then we can actually we can go ahead and keep this as just a c. We don't need that 1 because when I say how many c's do you see there, you're going to say there's 1. We don't have to write the 1 if we know that there's only 1 c. Okay, but this is it. Pretty repetitious, but again, use your calculators to try to help you with any fraction problems. Okay, you've got this. I believe in you. Just remember to like and subscribe. I've got 44 people that have liked and subscribed so far. Let's get that all the way up to every single one of my students this year, okay? You guys take care and have a wonderful day.